Here we go, exponential. And logarithmic. Equations. So that's the unit title. Notes number 1, solving exponential equations using a common base. Because you know I'm all about the base, no trouble. All right, so actually the first thing we're going to do is make a chart. So I need you guys to make this chart in your notes with me, and try to make it kind of neat so that you can use it in the future. Because I'll refer to this chart a couple of times today. This is kind of like the factoring chart, except I'm not going to just give it to you, we're going to make it. Okay, so I need 1, 2, 3, 4, 5, 6, 7, 8, 9. You need 9 columns, sort of evenly spaced out. 1. One, 2, 3, 4, 5, 6, 7, 8. Stick one over here. Okay, so down this first column, you're going to put X, 1, 2, 3, 4, 5, 6. Okay. So in this first column, we're going to find 2 to the x power. So I'm going to go through each one of these numbers is going to be my exponent on 2. So 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth, and 2 to the fifth. Oh, and 2 to the sixth. All right, so in the next column, we're going to do 3 to the x. So I'm going to do that same process. 3 to the first, 3 to the second, 3 to the third, oops, to the fourth, to the fifth, and to the sixth. So we're just going to continue repeating this process, changing the base. So now we'll do 4 to the first, the second, the third, and all the way to 9. But on like once the numbers get to a certain level, we don't have to write them all down because they get kind of big there at the end. So I might not do like the 6th power of 9. No. All right, so I didn't keep going down to the 6th power on 7, 8, and 9 just because those numbers get so big, and I don't think you're going to see those numbers in Delta Math. So I'm just going to kind of go across and make these rows. Ugh. Just messed up my beautiful chart. I mean, you certainly could fill in all those boxes if you felt the need, but I don't think that we'll need that. All right, I'll show you what we're going to do with this in just a little bit. But so normally in Algebra 2, we would make this as an index card that we would use as a reference for these types of problems that we're about to do. But we just put this in the front of your notebook and we'll refer to it a lot. So don't lose this page, it's important. Okay. So, exponential equations have x as the exponent. They used to teach you this in Algebra 1. I don't know that they have to do that anymore. So I don't know that you've ever seen this. But it's a possibility. All right, so what you'll see is that you'll have this big number, which we refer to as the base. And your variable will be up here in the exponent. So we'll go ahead and jump into some examples. 3, 2x plus 2 equals 3 to the 10th. So these numbers down here are your bases. In this example, the bases are the same. When the bases are the same, all we have to do is set the exponents equal to each other and solve. So again, I've got 2x plus 2 equals 10. So I'm going to solve for x first by subtracting 2. And dividing by 2. So because the bases were the same, I ignored them. I didn't have to use them in my equation, But what we're going to find is the bases aren't always going to be the same. And none of the problems in Delta Math today are the bases the same. You have to get them to that point. So that's kind of the tricky part about this. So let me show you what happens when they're not the same. And I'll show you what you need to do. What if the bases are different? Oh my God. We have to make them the same. And the trick to this is that we have to make the bigger number appear smaller. So we got to do a little math magic. Are you ready to be math magicians? Okay, so I'm looking at the bases first. I have a base 4 and a base 16. I need to make 16 look like a 4. So that's when I refer to my chart. So since I need to make 16 look like a 4, I want to find 16 in that 4 column. I see 16 right here. And I can rewrite 16 as 4 to the second power. Okay, so 16, and you should be able to agree with me, 16 and 4 squared, they say the same thing. They just look a little different. All right, so it's like we took 16 and we squeezed it with a waist trainer. Right? She was a 16, now she a 4. She's like Khloe Kardashian or something. Nothing? Nothing, people? What else? All right, so I've got 4 to the 4x plus 2. I can't make that small number look bigger. I can only work with what I have. So I'm going to take that 16 and rewrite it as 4 squared. But I have to keep that x minus 3 that was living there before I did all that. So I'm going to put that in a set of parentheses off to the side there. So now that the bases are the same, I can ignore them and solve. So I'm going to take 4x plus 2 and set it equal to 2 times x minus 3. So a little bit of equationing here. We've got 4x plus 2 equals 2x minus, almost made a mistake, minus 6. When you're solving these, couple different ways you can go here. I always prefer to subtract the smaller amount of x's from the larger one first. That's my personal preference. 2x, or 4x minus 2x is 2x plus 2 equals negative 6. Subtract 2. 2x equals negative 8. Divide. X equals negative 4. Okay, I'm going to do one more with you real quick before we go to lunch. So we've got 32 x plus 5 equals 2 x plus 5. So I'm checking out 32 and 2. I need to make 32 look like a 2. So 32 equals 2 to what power? So you refer to here, so I'm looking in the 2 column. There she is, 32. So that's 2 to the 5th power. 32 is 2 to the 5th power. So I replace 32 with 2 to the 5th. I have to keep that x plus 5 that was there. And all of this remained the same. I didn't touch any of that. Once the bases are the same, we ignore them and solve. So I'm going to grab 5x plus 5 equals distribute Alright, I'm going to finish this with you guys. They're going to go to lunch. Minus x is 4x. Subtract 25. And divide. Oh. Okay. So you guys should be able to work on your Delta Math assignment. There are 6 problems there for you to do. And if you have any questions, just let me know.